What's up, guys? My name is Cornelius Robinson, and this is Overshoot. Today, I want to do a little bit more of an informal episode. I want to take a look at the code behind the simulation models. So we have a really simple circuit right here, and what makes this resistor work, let's take a look at it. Here's the code for that resistor. Now it looks like a lot, but I'm going to go through it. It's really not too bad. Up at the top here, we have a couple of constants. Each one represents the two terminals on a resistor. So if we go to the schematic view of this resistor, you'll see P1 and P2. Okay, that's our input and our output. Now looking at the code, these numbers here correspond to the actual terminal. So if I select a terminal here, right here, this object ID, that is how we identify this particular terminal. Now each terminal has its own object ID. Okay? Now I'm going to skip over these constants for now, and we'll take a look at the rest. So we have three different events, if you will. We have a setup event. This is what tells Flux what the component is and how it behaves before the simulation even starts. We have a before event. This tells Flux how to calculate the component for each step cycle. For example, if I go back to my simulation here, you'll see a step size and simulation time, and we can also increase or decrease the simulation speed. Now your computer will calculate the circuit for each step. So if we go back to the code here, the last event that we have is a calculation event. And we'll get into that more a little bit. Let's go back up to our setup event. In the setup event, we have a resistance constant, and that is set to the property resistance or the value of 500 ohms. For example, if we go back to our simulation here and we select this resistor, you can specify the resistance here, and that value will change in the simulation model when you change this number, or it will resort to a default of 500. Okay, then we call a simulation model. We set the type to resistor, and we set the resistance to resistance, or this constant that we have up here. Next, we need to map the terminals. So we have an input terminal, and it is set to P1 terminal, which is referenced up here. And we have an output terminal, which is referenced to this constant up here. And that's basically how you set up a simulation model inside of Flux. It varies per part type, but in general, this is all there is to it. Next, let's move on to the before event. Now this is going to be extremely similar to our setup, but Flux will use this before step event to recalculate the resistance on each step cycle. So if the resistance property gets changed in the panel, like I showed you here, it will recalculate the resistance before that step. Now I want to move on to the calculation event. This starts out relatively similar to the previous events in that it calls the resistance property. However, this also allows us to calculate other properties such as the voltage on each terminal, as well as the current, power, and voltage drop. Now, when we're simulating the part, that is what allows us to view this number up here, and we can toggle these on or off accordingly. Now I want to take a look at one more part that is slightly more complicated. We'll take a look at this LED here. Okay, just like before, we have our two terminals. We have our anode and our cathode. And if we take a look at the code, this is going to be pretty similar. We have our terminals here, anode terminal and cathode terminal, as well as some other constants like before, output voltage, input voltage, and so on. Now for this setup event, we have several other variables besides just resistance. So in this case, we have a forward voltage, a series resistance, emission coefficient, saturation current, and breakdown voltage. Now all of these can also be specified by the properties. They also have default values that we can use, and you can find out more about those values in the flux documentation. All right, just like the resistor, we have a simulation model that we call. The type in this case is just diode. And then we have the various properties that we can set. Just like the resistor, we have our before event and our calculation event. I'm not going to go into too much detail with this calculation event just because it's not yet well documented, but this is a really good example if you want to get into it. I hope that's been helpful, guys. I know this is a bit different from my regular videos, but I wanted to get something out to kind of explain how the code works. Again, you can find more information at docs.flux.ai. Make sure to like and subscribe, and I'll see you in the next one.